Right, so hello everybody, good morning, good afternoon, good night in my Truman Show world. Welcome to day 2 of the Poet Summit. And just before I forget, if you haven't sent your poems in, you've got to send them in. There may be prizes, there may be programming prizes. So send them to poetsummit@consultingwerk.de.com. Oh, okay, so there's 3 of you at least that have sent one. My microphone doesn't work? It does? Oh, I must just speak louder for you? Or for the room? Okay. So don't forget to do that, and we will have fun reading those later. Or, you know, if anybody has a dramatic voice, we can read them out. So, why am I here today? To talk about config files, which is the most exciting topic in the history of programming. But basically how we can work with config files, JSON, and reflection or dynamic programming and make your life eventually easier. That's the point of today. My name is Peter Judge. I work at Progress. I've been there for some time now. I'm still a programmer. I still like to think I'm a programmer. I still write code. I try. Mainly I work on paths integration stuff, but for this purpose, I am a programmer today. I'll just skip over that because we got a short one. All right, so we're going to talk about config files a little bit, JSON and ABL. How do you read JSON if you don't know what it looks like? How do you read code if you don't know what it looks like? Well, how do you read classes if you don't know what they look like? And then putting that all together. So, what is JSON? Everybody knows what JSON is, but just as a quick recap, this is from JSON.org. Basically, it's a simple structured text format. That's the gist of it. It's always UTF-8, which is nice. You can have arrays of mixed types. You can have what they call objects, which you can think of as maps or dictionaries, basically name-value pairs. And the value can be another object or an array of things or a primitive value, if you will. So numbers, well, primitive values. Numbers, strings, logicals, nulls, and what did I leave out? And then arrays and objects. It only has 5 or 6 data types, which is nice and easy if you're typing stuff. It's awful if you're trying to read it into a pro data set or a temp table. It's awful, but it's just awful if you're trying to convert it into better, stronger types, right? Because we'll see in a sec. Dates in particular are strings. So how do you know it's a date? Oh, it begins with a 2, 0, 2, 1, dash, yada, 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 yada. Okay, well, that could be your order number, right? It could be anything. So thinking of how you convert dates in particular are nasty, into or from strings is a pain. At least they are spec'd as being ISO 8601, which is a good format, but you still got to convert them. Numbers, there's just one number type. Decimals, integers, whatever. There's exponential types as well in JSON, which we don't support in ABL. We'll get to that in a sec. And is there a schema, JSON schema? I mean, there is JSON schema, but it's not really, you know, W3 seed, and it's not really RF seed, and blah, 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 blah. So it's just a thing. It's pretty nifty, JSON schema, but it's not formalized at all. So a lot of the time, it's just, well, we'll see. We'll just a little bit of code and pray. So in ABL, there's a number of classes that were introduced in 11.0. Prior to that, you had to do a lot of fun things with strings and tildes and curly braces, and then you forget the tilde before the curly brace, and then the compiler crashes, and yada, yada, yada. As of 11, just don't write code earlier than that, but just stick with it. JSON object, there's a Progress JSON object model namespace, and the ones we really care about for this purpose anyway are JSON object, JSON array, and JSON data types, as well as the object model parser. And that is our friend for loading stuff in. If we're reading files off disk, object model parser, and in other places too. In ABL, JSON has to have an outermost array or an object. Like formal JSON is allowed to have just a primitive value on its own without any square brace or curly brace. So you can have a null or a string or a date, well, not a date is a string, a null or a number or whatever without curly braces. We don't support that, unfortunately. It's not, does anybody run into that when they try to read stuff from a web service and they just send you a string and they say it's application JSON? Yep, yeah. Temp tables and data sets can do a read JSON, write JSON as of 10.2b. We're not going to touch that now. We won't talk about that much. Generally, I know Mike yesterday spoke about how his config files are basically just pro data sets or temp tables serialized to XML because he's lazy. This is the talk for not lazy people, or less lazy people maybe. But we will talk about how you read unformally structured or untemp table structured data sets. All right, so how do we create a JSON document? There's a couple of ways. One is we can do our friend the curly brace thing. Tildes and curly braces. ABL is awesome. We can parse that using the parse method on the object model parser. And as you can see, this is kind of a pattern that I tend to use a lot because I am somewhat lazy. Just new blah, 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 colon parse instead of holding a reference to it. There's nothing else that this class does. It just reads data in, reads it from a file or reads it from a mem pointer or a long char. And I'm sure, and it's a built-in object, and the cost of doing this is really low. And yes, that's probably not the best way to do it. I should probably have a variable and keep it in there and blah, blah, blah. But anyhow, so that produces a JSON construct. If you're not used to this syntax, this is 12.3 and older. And I always thought of myself, oh, I like my defined variable statement. And as soon as I was able to use something like, ooh, var, it's very cool. It's very fast. It's like just clicked in my brain. But it produces what's called a JSON construct. A JSON construct is the parent of an object or an array. And so we have to check what type it is with a type of statement to know whether it's a JSON object or a JSON array. And as you'll see in a bit, each of those we work through them, or we deal with them, we read them differently. And we can also read from a file. There's the parse file, cunningly named. You can pass it a file name, and standard rules apply. Is it in ProPath, or is it relative to ProPath, or can it be found? Boom, and it reads it in. So that's how we can create. This is how we would create JSON or file config files. We can do the same thing, creating them over here with just that produces exactly the same JSON on the my left, your right. And there are a couple of ways to get JSON documents into pro data sets, temp table data into JSON. The JSON object read is one way, so that just sucks a buffer handle in. And that's functionally equivalent to the write JSON method on a temp table or a buffer handle. So that's how we create them. We're not going to talk too much more about that. Oh, I did want to say, if anybody had any questions, feel free to interrupt me or ask them as we go. I'll take them as we go through the thing. The
JSON construct, is it as old as a JSON array, or is it used the same?
Yes. So the question is JSON construct as old as, or was it introduced when the JSON object and the JSON array were introduced? The answer is yes. The object model parser, I believe, this was all at 11.0, all released then. This is, as I say in my comment here, people tend to assume that it's an object or an array because they know the structure of that document. And I deliberately put this in here because kind of the point of this is you may not know exactly what that structure of that config is like. The point of what I'm trying to get across anyway today is how you can take a random JSON object, JSON document, and read it and assign values into ABL objects. So typically you wouldn't do this type checking. You might just do the cast right up top here. Most of the time that's what I'll end up doing because I know that the document is at least a JSON object. I may not know the exact structure, but I know what the document is. Yep. All right, reading them. We're going to work today, I'm going to work through examples with, this is from our logging infrastructure. It reads a JSON file over there. And we can read this document to do various things, to do what we need to do. So when we're working with objects or with arrays, right, and you'll see I kind of use this notation a little bit. I'll have this kind of shorthand, get or whatever, index and name. The methods for working with arrays and with objects are very, very similar. With arrays, you work with an index, right? Which number in the array is it? It is ABL counting, so it starts at 1. 1 base counting, not 0 base counting, but and with objects and their properties. So we have kind of here, we have one object out there, we have another one called, a property called logger, which contains another object, and then we've got a property called OpenEdgeNet server connection client socket, which contains another object of log level, which is a property with a character, and filters, which is an array of either characters or objects. Right, so that's our structure here. When we're dealing with getting data out of an object, we say get property name. And the very, 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 very important thing to know is that in JSON, property names are case sensitive. In ABL, they are not. So you will no doubt run into cases where you think you said file name without a capital F and a capital N, or file name with a lowercase f and a capital N, and your code, your JSON document is different. Mike?
Peter, if I got you right,
You said that in ABL, JSON property names are not case sensitive?
No, I said they are case sensitive. They are most definitely case sensitive.
Yeah.
The ABL code is not. And so, when you have a case statement or an if you're looking for a property called name, you might want to check for capital. It's less when you're reading it. Sorry, it is when you're reading it. But if you say name like it's written there, all lowercase, or all capital NAME or capital NAME, there can be 3 different properties of that name. That was a bad choice of example. Append to, whatever, pick any one of these, right? Filters. There could be 3 properties named filters with any variation on casing. So you've got to be quite careful about that. The way I tend to work around that, Patrick, I'll get you in a sec, the way I tend to work around that is I use OOABL enums for the actual names, because then I write them in code and then I just reference them and then they work. Question?
is it a best practice to use either lowercase or uppercase?
So the question is there a best practice to use lowercase or uppercase? Most of the JSON properties I see are named camel case, so lower first and then uppercase as you go. I've seen though, if you get JSON out of paths, out of the JMX queries, you get a mixed bag. Sometimes it's that, sometimes it's all, it's sentence case first, capital. It's up to you. Most JavaScript fundies tend to follow this kind of a pattern, but it doesn't really matter, right? You can do, I think you can have underscores as leading characters. There's some limits on the names. You can't have an empty property name, for instance, just a blank string. Sorry, no, you can't. You can't have an empty one, but you can have leading underscores, and there are some restrictions that I'm not sure of, but many people tend to follow this, but as you can see, not even me, right? Donk OpenEdgeNet server connection client socket, and you'll see why we do that in a minute. Mike.
When you talk about properties, one thing that can be irritating, JSON is syntactically correct if you repeat property names.
So to Mike's comment was, JSON is syntactically correct if you repeat property names. So if I said name, file name, file name, file name, file name, file name, file name, append to, we will take, I think, the last one when we read that data in. Right. The reader's got a little bit of flexibility in it. Sometimes it reads stuff that it shouldn't. So if there's malformed JSON, the object model parser will parse it anyway, which is a bit annoying. But so to get data out of this, there's a bunch of get methods that do the conversion to ABL data types. Get integer, get int64, get longchar, get date time, all of those data. Handle, there's a com handle. Like, why you would have a com handle in JSON document, I don't know, but there's a get com handle method, right? Somebody really updated the app builder, I guess, but I don't know. So all of the data, so we do conversions when you read them out from things. These follow the Yoda approach, which is just do. There's no trying. You can't say, is this string a number? Is the string a date? Is the string binary data? Because binary data is encoded as base64 encoded data. It just tries to pull it. So if you do get date and you've got a long char of 2 gig or whatever in there of base64 encoded data, things are going to go poorly for you. it will throw an error. So you need to typically do a bit of upfront investigation. Thank you. Good word, Paul. There's also a getJSONText method, which I see fairly frequently used. And it just returns a long char, and it just returns the JSON blob, basically. And that's fine because it always works, right? This will never fail because it's always JSON data. So if you say get JSON data on a logical value, Boolean value, it's going to return the string true or false to you. If you do it on a character like this, right, it's going to return whatever that says, name, file writer, or socket log. If you do it on a date, it's going to do that. Where it becomes annoying, or where it becomes tricky, is if those values contain escaped characters. So if you have a URL in there, http://www.poetsummit.org, we will return /http:// yada, 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 yada. So that may not always work, right? You may not actually want that. You may want the strings. So that's the thing to watch out there. Sometimes you have to do this, right? Sometimes if you want to figure out if a number is a decimal or if it's an integer, right? To do the conversion from a JSON number to an ABL number, you've got to get the string value and say, is there a dot in it? That's kind of how we do it. Is there a decimal separator? That was the word, right? Is there a decimal separator? Yes, there is. It's going to be a dot always. You don't have to do it with session decimal separator, but you may want to read the string value to figure out what kind of a number it is. Fun, or can be fun. And these work really well when you know the structure and you're guaranteed of the same structure, because you can just say, oh, I know that property is, I know there's a property of this name and it has that data type. But that's not always the case, and JSON documents are flexible in that the property name could be a string. Today it could be a string, tomorrow it could be a number, the next day it could be a logical. You don't always know.
Does getJSONText also give a whole object or a whole array?
Question is, does the getJSONText return an object or an array? Yes. So if you said getJSONText on filters, or filters getJSONText 1, 2, so you wanted to get that value out, it would give you the whole array, but not as a proper object, as a stringified object. So again, this is useful, it has its cases, but I've seen lots of people use it just because it always works, and that's not always the right reason to do that, in my mind. All right, so if we don't know what the document looks like, how can we read that, right? So the first thing we have to do is it an object or an array? We know it can be only one of those two. And as I said earlier, usually you assume you know, you have some, if you're reading a config file, you can assume that, but you may not. So we check the data type, which I'm not doing here, which I did in my earlier slide. If type of JSON construct is, or the object is array, cast to an array. If it's an object, cast to an object. The next thing we want to do is start looping through and working down. So we can say, if it's an array, we know it's got a size, right? It's got a length. It's either 0 or a positive integer. It's never going to be negative. If it's a object, we can say, let's get the names, which returns us an array of characters. And that's all of the property names. So again, file name, if you've got 6 different cases of it, will appear 6 different times in there, but you will get all of the property names with this thing. There was a bug where if you have very big JSON documents, this blows up an internal progress limit. So I tend, for safety, to use long chars. It just means I have to have another variable to assign the stringify the value back. So the individual property names are not 2 gig big, but the whole, it blows up at basically an internal array limit. So as I said, case-sensitive property names that may or may not bite you. It may or may not be important. Again, if we're reading JSON config and we're setting it just into basically a value object that just holds data, does it matter? Probably not if there's file names, right? You may have a bug because the third file name property spelled with a capital F is the wrong file that you're expecting at the lowercase file name version, but that's fairly easy to figure out. When we loop through, as I said, when we loop through the JSON array, we go through its length property, which is the number of items in the array. Unfortunately, or well, I say unfortunately, there's no real JSON path construct like there's XPath. There isn't really a solid one that I found in the wild. There's a couple of implementations, and there's definitely not one in the ABL. So if you want to work through a document, you can't say, you know, get me the 7th item of the array that's under this property, under this property, under this property. You have to, lots of loopity, 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 loop. Mike?
There may be third-party frameworks for the ABL that provide that feature.
Sorry, I couldn't hear. Mike's comment is, some people might have written that. There may be third-party frameworks. You can write that stuff. It's just you got to write the stuff and follow some form of syntax to get the pathing. But generally, for this kind of stuff, you're just going to start at the top and loop your way down. The pathing stuff is could be really nice, right? If there was like a JSON path and we had runtime annotations, there we go. That's a nice combination because you could say on an object, you know, this property gets its data from that JSON path, and then you could just read the doc and go down. And you can build all of that stuff yourself in ABL. I'm not going to talk about that today, but there, you know, that's a good way of doing that, right? You have to today. You can generate, you know, you'd have to compile the code with XML or XREF, pull the annotations out, store them somewhere else, read your annotations cache, read the. It gets a lot, but it's a lot of effort, but you can do it. So you could do some kind of a more structured thing, kind of like how Spring in Java does it, right? They just say that's the property, and then it just magically happens. All right. So once we have a property, right? We've looped through all of our properties. What is this thing, right? So we can do a couple of things. Firstly, we can say, if we expect certain structures, we can say has. Does a JSON object have a property called file name, or capital F file name, or uppercase file name, or lowercase file name, or all of that, right? We can do that. Once we have a property, we can say, what is its type? What is its JSON type? With the get type, again, index or name value. So this works for arrays and for objects. And it gives us a value of JSON data type, which is just an integer. This was introduced in 11.0. Formal enums in the ABL were introduced in 11.6. And so this is just an integer value. So we've created in the OpenEdge core library a proper formal whatever enum that just maps it so you can pass it around and get a little bit of better strong typing. But 6 data types: string, number, boolean, object, array, and null. Null is a legitimate data type. Right, so on the right over here we can see we can loop through them, and you know, if it's a string, do something. If it's an object, recurse into it. If it's an array, go back into it. Numbers, boolean, nulls, and we can do some work on that. Then 10. Go to 10. That doesn't actually work. And again, you can kind of just you can stack. You know, you can do get JSON object. This is slide code. Typically, I'll say they'll be at a has. You know, does JO, if JO has logger, then, and JO get type logger equals object, then get JSON object, right? Just to be really defensive with the stuff, because as I say, there's no requirement that the JSON is in any structure at all. You have no guarantees. So you have to do a lot of belts and braces coding. You don't have to, but it's probably a good idea to do it. Okay, so data type mappings. Fun, fun, and fun. As you can see, string can keep all of those, right? Characters, long chars, easy peasy, right? Dates, datetime, DZ, TZ, however you want to pronounce it. Main pointers, raws as base64 encoding. The timestamps at least are in a formal specified format, but you've got to know that. Numbers, pick one of those 4. Again, with handles, I don't know what you want to do with a handle in a JSON document, but you can have it there. Boolean type. The one thing to note with arrays is arrays are can hold anything. That don't, so in ABL arrays you declare it as a character array or an object array or a integer array or whatever it is, and it just holds one data type. Arrays in JSON hold or can hold anything, any combination of data types, including other arrays and objects and everything. So don't assume when you're reading an array in that it's going to be, that everything is the same data type as the first character. In 11.7.6 and beyond, we created a class called the JSON converter, which can help you to convert those into object instances, ABL object, which is there's an interface called primitive holder, and it will bring you back the right thing. So it knows how to pass strings, particularly. A lot of the code is around passing strings into dates or datetime TZs, and it just gives you an object which wraps the value. I'll talk a little bit about those probably in my next session, which is later today sometime. So, conversions, right? So now we have ABL data types, whether they're objects or whether they are primitives. So primitives, I mean these data types, right? There's no object to object direct mapping. That's what we're kind of talking about here. All right, so before we go any further, I'll just go and attempt a little demo. I am historically awful at doing demos, so I apologize in advance for it failing, because it's almost likely to fail. All right, so the first thing is we're just going to read this config file, right? This looks very similar to what we saw earlier. The names are slightly different. We have, we have this object, and then we have another object inside it with two properties, filters and log level, right? So this is, as I said, this is taken from our logging infrastructure. This is what the file looks like. And so we do pretty much this stuff to read the JSON in and set object values based on the JSON values generically. And so if we want to, if we do our runner, we have a logger builder, which I didn't open here. So we say, give us a logger, and we're going to write some data into it, right? So if we run this, it's going to do something. And it's going to write our little file out, I hope. Refresh our project. There we go, socket log. And there's our messages, right? So the code actually works, so I'm happy about that. But the thing we care about here is how do we go from here to there? Well, we use our config file. Our config says do these things. And so we have a logger builder class, and this is a very simplified version of what we ship. But so if we go and look at our getLogger method, yes. My resolution's a little low. Okay, personalize, It says it's good. Okay. Thank you. So we get our logger, and so what we do here is, the moral of the story is we'll end up calling, when you say get logger, we do a get logger instance. This again is, this is a factory pattern, but we say get the logger instance, we read that file name, so we say file info file name, file info full path. Again, I'm assuming it's JSON here because I want it to be JSON. You could check. We get the names, and we basically loop through. I'll put this on the side so we can see it. So we loop through over here. We get all of the names of the properties, which are, this set of properties over here. And if this property name matches what we asked for, which would be that, then we can read into it, right? So we can just dynamically read it. Again, this is just a simplified example. We don't read the file every time we do a logger, but and then we can loop into it. So if we had a second property over here called Bob or Bob Sophia, we won't go into that object to read anything because we've said we asked for this, we're getting this value, right? So we go get a value, we get a build logger, and now we go into the details of all of this, right? And so we loop through it and we say, well, if it's a string, we go get character for a log level, right? Because again, we're making assumptions here. But for the details inside of this filters array, this is kind of where we're going to now. We know we have two data types. We have a string and we have an object, because the objects have got more values or more data in them than the strings. So we can go and say, if it's a string, we say, well, that's the data type, or that's the object type, the class name, if you will, of the filter, or it's in that name property. So we have those two we've pulled apart here, filter type, get character loop, or get character over there. And really this code should be better. We should have an if options has name, really, because somebody may not put it, right? So if there's a name property in this object, in this child object, then we assume that there's an object type name and we can read more, right? So that's the first kind of level of looking. Second is we want to build objects out of these. And so we have some code that says, well, if, so this filter type over here, we've said ProgressLandClass, get class, and this is a way to get from a string class name to an instance of ProgressLandClass, which is the internal representation, if you will, of that class. You can do this with all types. There's other ways of doing this, but if we're reading text-based JSON or if somebody's typing in text values, this is how we get it. I would only use this getClass method for stuff like we're doing here. If you're writing code and you're trying to find class names, you're trying to find ProgressLandClass instances, and you put a quoted variable in there of a class that you know exists in your ProPath, I will hunt you down and beat you with a wet noodle. You shouldn't be doing that. You should be using the getClass function, which is strongly typed, and it will save your life because you won't break at runtime, you'll break it at compile time. Anyhow, so we have a filter type, we have a type name, and so when we say if it's a file writer, then we go and look for a file name, and we say if we have a file name, we go, oops, come back here. We go instantiate that class, right? Dynamic new, we give it a file name. Again, there's other ways of doing this, but dynamic new file name and pass in the file name because that's what this class expects. If we take a look at the file writer class, there's a immutable property, private set, and public get for a file name, right? This one this one is uppercase F, lowercase, uppercase F, uppercase N, and we pass it in over here in the constructor, and then we write data out when we call it. We don't care about that right now. So that's what we're doing in our builder over here. Creating the thing, we know for a file writer it's expecting a constructor argument of the file name, and so we can just pass it in. And everything else we're like, I don't know what to do with this thing. So we had another one over here, which was our full text format. And that has no constructor, aka just has a default constructor, right? So it just says, take the value, and I'm happy with that. All right, so that's easy peasy, right? We just write that. Every time we add a filter, we add a new if statement in our block here. If we have a, I don't know, a socket writer, or we have a Elasticsearch writer or something fancy like that, we just add another if statement, right? And then we're all done. Cool? Not so cool, because now we have to add more code to do the same damn thing every single time. We can do some of this with different reflection, but today we'll not focus on that, right? So how do we, so we figured out now how we get from, and do my focus here because that didn't work yesterday. So how did we get from, how we can get information out of the JSON document? We've just seen how to do that, right? Properties, values, data types, all structure, all of that stuff. How do we get it into an open edge, an ABL object? So OOABL has been around since 10.1a. I'm sure you can do a lot of this. I'm sure you can do some of this with procedural code and inspection over there. It also tends to be more of the Yoda method, where you just try it, and if it works, it works. If it doesn't, it doesn't. But one of the nice things about ABL is built-in reflection or introspection capabilities. We'll talk about those in a sec, but how you can see what an object is made of, which is very, very useful. So just as a super high level, we're going to kind of look at 3 simple public members. Members are just the things in classes. Variables, which are always readable and writable, you can't restrict them. So you can say they're either publicly accessible or not, basically. Properties, you can control read and write behavior. We saw that a little bit there with that file writer property, where we said we can read it publicly, but we can only write it privately, in other words, in that class. And methods can do pretty much everything, right? Any combination of input parameters, input, output parameters, return values, whatever. They can have almost any ABL data type, except pretty much for temp tables and data sets and buffers. Primitives like characters, integers, logicals, raws, whatever. They can be arrays or non-arrays, scalars, and they could be built-in ABL types. So you can have a property that is a JSON object, or you can have a property that is your own type. Data structures tend to be handles only, right? So that's the framework we're working with. What reflection and introspection do is they let you look inside of an object at runtime, see what it is, and then change that or alter that dynamically without having any predefined knowledge, really. In ABL, I've talked about the ProgressLandClass object. That's the gateway drug, if you will, for reflection in ABL. Everything goes through there. And you can get that in 3 ways. 3 ways. Firstly, if you have an object reference, you can say get class. So if you have an object reference of a file writer, for instance, you say, hey, that object reference, who are you? Or what kind of thing are you? You say get class, and it returns your ProgressLandClass instance, which is another object that you work on. You can use the get class statement or function, which is 11.6, 11.5. I can't remember that time, get class. Do you remember, Mike, when that was introduced?
11.4 or 5.
11.4 or 5-ish time frame. So old enough that it should be there in your code, right? And that's really nice because that lets you put an unquoted type name in. And that's really nice because that means the compiler says, is there a class called file writer in ProPath? And if there isn't, it gives you a compile error, not a runtime error. And finally, the one we saw here, ProgressLandClass, get class, where we take a stringed version, right? So when you're reading stuff off disk, you can't check that in advance. But once we have one of those guys, we can do a lot with it. A lot. So this is some of the methods on it. The doc is up there. They are pretty much like get variable, get variables, get method, get methods, get property, get properties, right? So one will give you a list of, one will give you an actual variable or an actual value. So for instance, we can say get property, we give it a name, get property file name, and we give it some flags. And by default, the flags are public and instance, but we can say I want to see all of the static private properties or whatever. Other languages, or some other languages, let you call private members through reflection. So if you have like that private set we saw, if I try to call that from ABL code, the compiler would say it's private, you can't do it. Some other languages let you call that private set through reflection. ABL does not. ABL reflects. ABL respects the same rules that the compiler does, basically. So you can't call a private setter via reflection or whatever other member it is. So we have these flags to say, I want to see basically the default is the public instance ones, because that's what we want, because that's what we're calling from the outside. We can get methods, properties, variables. The get, this just kind of brownish, orangish color, is just for methods where you can, because methods can have many methods with the same name can have a variety of parameters or parameter lists. And so we're not going to talk much about, or at all really, about reflecting on methods and using those to set. We're just going to talk about properties here. But you could do much of what we're doing here with methods as well. You just got to figure out, well, I've got an input parameter of my JSON object is a string. I'm looking for a character or a date or something. Here's the method name. Is there a method with this name and one input parameter and no return value, a void, or you don't really care. So you can do that as well. We won't talk about this today. So we get return values of one of these three types: progress reflect method, progress reflect property, progress reflect variable. And these give you a bunch more information, right? Of course, it's just like turtles all the way down. So properties, the things that are useful here, there's more than just this: the name, the data type name. So that would be, if data type is ProgressLang object, which is how we'll end up doing it. So that would be character or ProgressLang object or integer or int64. But if it's ProgressLang object, the data type name, mirror.filename, file writer, right, in my case. Does it have an extent? Or what is the extent, right? So it will be 0, question mark, or a positive integer value. 0 being scalars, non-array variables or properties. Question mark indeterminate, and with a value, right, if you've defined it that way. Can you read it and can you write it? Very important for what we want to do. And access mode, which is also important, particularly because we can drill down into the setter access mode, because we want to set some values here. Methods and variables have similar things. Variables have less stuff. Remember I said variables you can't control the get and set differently. And generally speaking, I would not recommend using variables as properties kind of by convention. You can use variables like you would properties, make them public and readable and writable, but I know it's just a bit of a smell to me, but they work just as well. You just lose the thing you lose with using variables over properties is properties give you the option of having custom read and write code, which is really nice. Again, methods, the important part here then is num parameters and what those parameters are. And you can, again, drill down into the bottom right here, and we can see the parameters have a name and a mode, input, output, a position, so 1, 2, 3, 4, 5, and again, data type, etc., etc. So we can get from an object, from a class, right, because all objects of a class have the same stuff in them. We can say, give me all the properties, give me their names, can I write to them, etc., etc. And you can see where I'm going with this, I'm sure. So, talked about this a little bit now, where we drill in, as well as the parameters, right? So, putting it all together, we have a couple of approaches to do here, right? So we've got the ability to look into the details of the JSON document, and we've got the ability to look into the details of the progress object. And so if we want to map those two, we can take two approaches. We can read the document and just slap everything onto the object. We can read the object and pull everything from the document. So those are kind of the two broad approaches of reading, right? And you can choose which one you want to do, right? The code just works slightly different in the sense of, does it have one of these things and I can access it? Another approach is to let the class determine the format. So we added, again, probably in about the 11.5.6 time frame, packages in the ProgressIO namespace for JSON serializer, which takes an object. If an object's defined as serializable, there's a serializable keyword on the class statement and on certain of the members. You can just say, hey, serialize and deserialize this object using the built-in Progress serializer. Works really nicely. It's just ugly as sin. It just doesn't look like anything you'd want to do, right? Because it just writes it out in the internal Progress format, which has got a whole bunch of bookkeeping in it as well. So so things like there's a version number there. If you have two properties which hold a reference to the same object, we only write the one object out, and we just say this one is the same as that one, that kind of stuff. You don't really need to know that in your code. It chooses, as I say, it chooses a format. We read the JSON, set the values. We read the JSON and look on the ABL class, right? You can do a variety of these things. Talked a little bit about the JSON parse stuff as well. And then the last kind of thing as well, writing JSON out again is possible doing this. So writing JSON out again, you would have to, instead of looking at what is settable, you would have to look at what's readable from that thing and make decisions on, are these objects serializable or not? And that information is also available to you in the Reflect classes. So for what we're going to look at just briefly, I think it'll be briefly, because I've got a whole minute left. We're going to read the JSON document. We've seen that. into a JSON object or array. We're going to instantiate an OOABL object, and that is a whole talk on its own. If you have a name, how do you turn it into an object value? For what we're doing here, we're just going to say what you gave us is actually a class name. It's not an interface name. It doesn't have to go through a factory or a service manager layer or anything like that. That's the name of the class. We will instantiate that for you. And then look at all the JSON values and try and set them on that object. So let's go take a quick look at that. So the first thing, so kind of what we're going to try to achieve is basically get rid of this whole block, right? Or simplify this block drastically. Because, and the reason why we want to do it, or why I want to do it, I don't type. Yes? Better? And when I stand up, it's going to fall on the floor. So as long as everybody knows this. I don't like seeing case statements like that based on type names. It's a smell to me, and I'd much rather have it done generically, even if it's more complicated at first, because then it's done, and I never have to look at it again. And you know, I don't like looking at my old code again because it scares me. So that's kind of the gist of what we're trying to do. So the first thing we will need to do is we can make some constraints on our code. So the first thing we're going to say is, well, we want to set, for instance, this file name property.
The font size almost twice as big.
Can you put your glasses on?
The font size in the editor twice as big.
Better?
Once more.
Once more? Once more?
That's
Yeah,
now.
better? Okay. All right.
Stefan Wilson says, oh yes.
Pardon?
Stefan says, oh yes, so it's not just me.
All right. So we can make a couple of assumptions about our code. One is that we can require them to have a certain structure. Interfaces are really good for that. You can see I've got by the naming convention. The one thing that interfaces don't give you a guarantee of is the constructors. Right? The constructors are how we instantiate, how we run a class. There's no way to say this constructor must have these parameters or no parameters, or must be public or not public or whatever. That's just not in our interface definitions at all. So that's something you either have to do with, I don't know if it's possible with the SonarQube kind of tool, or you just have a coding convention that says for these kinds of classes they must have a particular structure and just manage it through code review. But in our case, we're going to say you must have a default empty constructor. So we can just go and add one quickly. Struct tor, and it's going to have to be public. And I just can't not. And I'm going to fix the spelling. I know it's bad. And then the other thing we have to do, if we want to be able to set values, right? So the reason why we had that file name parameter in the constructor was that we could guarantee it would be set, right? Because we knew there was one constructor, it took the file name, and it would always be set, right? Because there's no other way to instantiate this class. Now we can have a default constructor, and so in order to set the value, we've got to remove this private setter here, right? So now we've said this is just a default private set, which is cool. So we can now quite easily just go hack and slash, and basically we're going to say always instantiated with a default constructor. Again, we have the filter type, the ProgressLandClass instance that represents this object, this full text format, or the file writer object, and we can do stuff with that. So what we're going to do here is we're going to say new, which is the same as saying, I'll just undo my deletes here. This dynamic new statement that's highlighted here is functionally the same as this ProgressLandClass new method. So we're going to do that. And then what we also have to do is, and I'm not going to write this code right now, is I have a method called setOptions, which is basically going to say set options, and we're going to take the config, which is, our object name was options, right? And we're going to say filters index. Right, so we have an object over here, this JSON object over here. And so maybe what we do here then is do some type checking. Right, so we have a JSON object for this one, but not for that one. We have the object, we're going to say set options. And what this then does, and I will go reasonably quickly in the code I'll make available, we look through so what we're going to do is read the JSON properties, right? So pconfig is this object over here on the right, get the names, and then loop through them and try and set them on the object, right? So we get pfilter is our ABL object, OOABL object, mirror.filewriter. We get its properties based on that name. So, or we get a property, sorry. So is there a property called name? Is there a property called file name? And do something with it. This is just clean code, I suppose. Can we write the property? Can we set, is the set as access mode public, right? So can I set this value? If it's not, we just bail. And then we check if it's an array and do stuff. But basically what we can do now is we can, I was going to break that. I knew I was going to break that. We can say quite simply, so this data type over here, prop.datatype, right? That is a progress reflect property instance representing a property on that class. So is its data type character, yes or no, whatever. If it is, we're going to say, pull the value out of JSON, right? And again, you probably want more guard code than I have in here. This is just quite simple to say, you know, is the JSON value a character as well? So you would probably have us say, you know, we check that here. If the JSON data is a string and the ABL data type is a character, then we say property set, we give it an object instance, we give it the value. Decimals, etc., etc., etc. Dates and datetime TZs, TZs, we're doing a little, oh, I left something out there. We need to do that in there as well. Right, if the JSON data is a string, then we're just going to assume it's right? We trust whoever wrote this file, but you probably want to do more work around that and assign it. We can do similar stuff with objects, right? So if I have a property that's a ProgressLang object, if the data types match, the property data type name matches the JSON array or JSON object or can accept it, then we can just set them in there. And so we can just loop through and set that. And so we will save this and we can run it and it will work, guaranteed, right? Yep. Yeah. Okay. I am done. Ish. Nope, and it is not working. All right, well, since I'm out of time and I cannot follow my truism that every session is a debugging session, I will just stop here. This is the last slide, basically. And so the moral of what we tried to do was be able to take a file name property from JSON and set it into an object value. And why we wanted to do that is we can now extend both the object. So if we had an append to property, which I had planned to show, so we say, well, there's an append to, right? I want to keep appending to my log file. I can just say append to, public, append to as logical, get set, and then it's easy enough just to set another property in our JSON config and magic happens. I don't have to go and change the code to hard code it for a type and anything. And that's basically what I've summarized there. So I know I'm late, I apologize. If there are any questions. Pardon?
So what's the benefit over flat files that is stored in the database?
What's the benefit of flat files?
Over flat files that are stored in the database.
Well, how do you know which database to connect to, right? You may have dynamic configuration that you need to read before you connect to a particular database, or you may need usernames or tenants or something like that. So there are cases where you want to read a flat file before you do configuration. Other times you may want to, and in our case, in Progress's case in particular, when we ship code, we don't ship a database. You put the database together, you run your own database. I have no control over what's in your database or what the tables look like, or even if there is one. I mean, that's what that track's for, right? They care about databases, I don't really. And so for things like logging or other configurations, you may want an administrator to be able to turn stuff on and off. So if you look at logging in particular is a good example of that, where you may want to just bump up the logging level to, stun for, or trace or whatever, high logging level for 10 minutes because something's happening and then turn it back down again. Yes, you could change something in the database, but you could just as easily change a file on disk. Any further questions? That was... No? All right, well then thank you, and thank you for sticking with me so long. Have a good day.